The majority of threat actors buy and use commodity malware. To tailor this malicious software to their needs, they use malware configuration settings that allow them to dictate how it behaves. Parsing this data is an essential skill for any threat hunter or detection engineer, making learning how to use a malware configuration parser a must. Let me show you how to do just that. Hey guys, welcome back to the channel. If you're new here, my name is Adam and I teach everything CTI. I've helped build CTI teams, refine processes, and train clients on the best practices. Malware analysis is a skill that separates the average analyst from the great ones, and part of that is having the ability to parse a malware's configuration. Let's explore how you can do that to correlate intrusions, track campaigns, enrich threat hunts, improve incident response, and write better detection rules. There are around 5.5 billion malware attacks every year. It is used to gain initial access, move around networks, automatically exploit vulnerabilities, ransom victims, and exfiltrate data. Malware automates a human operator's actions, making it more efficient, scalable, and less error-prone. However, to be effective, malware needs to meet specific user needs. It needs to be able to exfiltrate data to a certain network address, install a persistence mechanism in a certain location, or only target certain victims. Malware authors must allow users to fine-tune the commodity malware they sell, which is where malware configuration comes in. Like any other software, malware can be configured to behave, function, or interact in a certain way using parameters, settings, or a set of rules. You can instruct the malware to communicate with a certain IP address on a specific port at a specific time once it has infected a target system, without having to build your own custom malware, a resource-intensive process. Threat actors will configure the malware they use for many reasons. They do it to adapt to changing circumstances, evade detection, or update its capabilities in response to security measures. They also do it to tailor the malware to their use cases, infrastructure, and objectives, changing communication protocols, adjusting the payload delivery mechanism, or even adding a new persistence mechanism. They also configure malware to add encryption and obfuscation to hinder analysis. Attackers will often configure malware with their own encryption key to protect it, or the data it is exfiltrating from detection and analysis by defenders. They also configure their malware to obscure the IOCs they leave behind. Detection rules can be created to pick up default malware configurations like mutexes, so attackers will adjust these default settings to evade detection. You may wonder why threat actors don't just write their own malware every time. Well, writing custom malware that evades modern security controls is a time-intensive and skill-dependent process. Most threat actors choose to buy malware as a service from affiliate programs. So why parse the configuration data in a piece of malware? Simple. To understand it better and understand the threat actor better. Parsing the embedded configuration details in a piece of malware plays a crucial role in quickly understanding its behavior and interpreting the threat actor's objectives. These details allow defenders to hunt for threats, build detections, and group similar intrusions into campaigns, allowing them to gain better insight into an adversary's capabilities. Even something as simple as changing the default installation folder or the persistence mechanism can tell you something about the adversary, give you something to hunt for, and allow you to correlate intrusions. Some things you can extract from malware are registry keys. This is a database that stores configuration settings and options for the operating system and installed applications. Malware will install persistence mechanisms in this database, so extracting this data can help guide incident response or threat hunting efforts. Domains, IP addresses, network ports, and user agents. Malware often communicates back to the attacker and has network information coded into it. Extracting this data can help you find additional IOCs to block or hunt for in your environment. File names and file paths. Malware is usually deployed in stages. An initial stage, executed by a dropper or loader, will download other components to provide additional functionality and capabilities. The malware will store these additional components on disk somewhere on the victim's file system. Extracting file names and file paths from the malware configuration details can help you identify these installation locations. Version numbers. Malware variants usually undergo iterations where the author adds or improves their functionality, just like regular software. This often means that samples contain version numbers that can be parsed and analysed against other samples or threat intelligence, allowing you to deduce the capabilities of that malware. Commands executed. Malware will be configured to execute specific commands once it infects a machine. Extracting these commands, or fragments of them, from the malware configuration data can allow you to identify other malicious behaviours and even the intent of the malware. You can use this data to hunt using the indicator lifecycle, write detection rules, or enrich your intelligence. The course of action you choose will depend on your intelligence requirements, tools, logging capabilities, and the type of information gathered. Hunting for atomic indicators like IP addresses or hashes is better than building a detection rule around them. Now you know the why, let's look at the how, by exploring the tools that allow you to parse malware efficiently. Parsing malware is difficult. You must know how to dive into the binary file and perform reverse engineering to pull out all the embedded configuration data. This requires expert knowledge, mastering complex tools, and is time intensive. A better option for many of us is to use a malware parser and automate the process. Malware configuration parsers are tools designed to automatically extract, interpret, and analyze the configuration settings embedded in malware. There is no need to spend time painstakingly dissecting a piece of malware to uncover configuration details. Just find or build a parser to match the piece of malware you are investigating, run the tool, and feast on the configuration details it reveals. Malware configuration parsers have several features and capabilities in common. Consider these when looking for which one you want to use, or when you want to build your own. The first feature is configuration and IOC extraction. All malware parsers are designed to extract relevant configuration settings and IOCs, including network communication data, file names and hashes, encryption keys, and more. They also include decryption and deobfuscation. Many parsers can dynamically decrypt or deobfuscate hidden configuration details, particularly ones that dynamically analyze the malware. Another shared feature is adaptability. Some malware configuration parsers can adapt to different malware families or variants on the go, whereas others are specifically designed to extract configuration settings from one type of malware, or even just one variant. Behavioral analysis is another factor that these malware configuration parsers have in common. Configuration parsers can be built into larger malware analysis tools like sandbox environments. These tools can automate the dynamic analysis of malware once executed and provide details about its configuration based on how it behaves. Some parsers also integrate great with other tools. To help streamline your investigations, it can be useful if your parser integrates with other malware analysis tools. This could be through inbuilt integrations into a SIM solution and threat intelligence platform, or custom-built integrations if the tool supports an API and scripting language. Another feature that tools have in common is automation and scalability. If you plan to analyze large quantities of malware, finding a tool to support volume and automated analysis is very useful. Many all-in-one malware analysis solutions support this functionality, but for a premium. The final factor that malware configuration parsers have in common is visualization and reporting. Several malware configuration parsers include visualization and reporting capabilities to help you understand their findings. This is a nice feature to have, but not necessary for an investigation. A malware configuration parser may not support all these features, but that does not make it a bad tool. One parser may be great at creating visual reports and able to parse configuration data from various malware. However, another may be great at parsing one specific type of malware. It is useful to build up a collection of malware configuration parsers to use on a case-by-case basis. You can generally choose from two types of malware configuration parsers. There is the off-the-shelf commodity parsers or custom parsers that you build yourself. Let's take a look at commodity parsers first. When first starting out with parsing malware configurations, it is useful to try out commodity parsers. These tools often don't require you to have a deep understanding of system programming or malware analysis. Instead, they are a point-and-shoot solution that only require you to upload a malware sample or run a command line tool. Many popular malware analysis tools like any.run, interanalyze, and VMray include malware configuration parsers as part of their all-in-one package. On the other side, you have custom parsers. If commodity parsers don't cut it for you, you will need to bring your own custom parser to the malware. You can do this by hand, going through a malware binary, picking out configuration settings, and then coding a tool that does this for you. Good platforms to do this reverse engineering include Hydra, IDA Pro, and Binary Ninja. But there is an easier way. The US Department of Defense Cybercrime Center has created a project called DC3 Malware Configuration Parser. This framework for parsing malware configuration information is designed to make building and sharing malware parsers easier. I highly recommend starting here when building a custom parser. Okay, that's enough theory for once. Let's see a malware configuration parser in action. In this case study, we will use the Department of Defense's Malware Configuration Parser project that I previously discussed. We will use the default PowerShell parser to investigate a suspicious PowerShell script that we found on a system. Our aim is to provide valuable insights to help our security operations team. To begin, you first need to install the tool. You can install the tool directly using Python's pip package manager with the command pip install wmcp. Alternatively, you can clone the project's GitHub repository and then use pip there. Now you can move on to the fun part. The DC3 MWCP project comes pre-packaged with several parsers you can use. To see what is available, run the command line tool and execute the command wmcp list. This command lists the available loaded parsers that you can use against malware samples. Here you can see 11 malware parsers straight out of the box. You can add your own parsers under these names by prepending DC3 to its description. You may need to add your local binary directory to your system's path variable if the command above does not work. To see what else the command line tool can do, execute the wmcp/help command. This brings up the tool's help manual. Let's try out the parse option. This lets us run any available parsers against the malware sample to extract configuration settings. In our investigation, you came across some PowerShell malware that needs to be investigated. You can analyze this malware using the PowerShell parser with the following command. Here, you use the default PowerShell parser. You can see it extracted a URL, protocol and domain name from the sample. These would have been set as the configuration options by the malware user. Extracting them can help in our investigation. Once you extract configuration settings, you can then move on to analyzing them. At this point, you have some network indicators to hunt for or pivot from. To hunt for these indicators, hop on your organization's SIM or EDR tool and run a threat hunting query. You could look for what other systems have communicated with this domain in the last week. If you choose to pivot on this data point using the indicator lifecycle, you can use a tool like VirusTotal to find other related data points to investigate. Searching for this domain in VirusTotal reveals that this is a potentially malicious domain associated with Luma Stealer malware. A good place to find other data points related to this malware is the Relations tab in VirusTotal. It provides other indicators you can look for in your environment. You can now write up a working intelligence report on what you have discovered about this malware sample based on its configuration data. The majority of malware seen today is commodity malware as a service malware that's sold by cyber criminals. Threat actors buy this malware and configure it for their attacks. Extracting this configuration data is a vital skill. It allows you to enrich threat intelligence, guide threat hunts, and build better detections. However, parsing malware configuration information is difficult. It is time intensive and requires a great deal of technical skill. An easier option is to use a malware configuration parser like the one I demoed. I highly recommend exploring this tool further and integrating it into your own threat intelligence, threat hunting, and detection engineering processes. Don't just track malware configuration data to paint a more accurate picture of your adversary. Stay tuned for more cyber threat intelligence and threat hunting content.